So now we will move to the presentation from the different projects, and I will start with a presentation from Hexa-X-II on this 6G end-to-end system. So let me jump into my presentation. I'm Sylvaine Kerboeuf. I'm leading and coordinating this work package 2 of Hexa-X-II on end-to-end system. And in Hexa-X-II, our starting point is that 6G is a platform that allows interaction with application to interact.
Sorry,
Yes.
We can see the agenda. We cannot see your presentation.
Okay, so let me. So I will start again. So let me know if now it's working.
You can see. Yes, it's working now.
Okay, so sorry. So as I was explaining, 6G is a platform serving application toward a wide range of application, user, vertical, and ecosystem. And the purpose is that this 6G platform will allow to have more interaction and adaptation of the system with the need of the user from the use case, and also the need of the from the society, and especially this value of environmental, social, and economic sustainability. So in order to design this end-to-end system, Hexa-X-II have been working on a comprehensive methodology that involve a top-down versus a bottom-up approach and a continuous alignment between those both approach. In top-down approach, we define some design principle, some system requirement, also the migration path to 6G and the system blueprint. And in parallel, we've got a bottom-up approach where the various technology work package of the project are working on developing enablers, including work package 2. And the purpose is then to have an alignment between the two approach via several iterations, and also by checking that the enabler under development can be integrated in the system blueprint. So we also built some system POC with selected functionality in order to evaluate the system design, and that we can achieve some important KPI and KVI. So let's go to this top-down approach. So we started with 10 design principles that we defined. You can see them on the left, and this principle mainly crystallize around simplification, meaning simplification, for example, with respect to a previous generation, having security and privacy by design, and also minimizing the environmental sustainability. And we also have defined some technical system requirements coming from the study of the 6 family of use case considered in Hexa-X-II. Of course, not all requirements are expected to be fulfilled at the same time or within the same network deployment. And we also added another technical requirements that comes from our analysis from the first workshop of SNS-JU project about this determinisms for the network, and having this aspect of transmission jitter and packet delay variation. Moving to the next slide, we also work on this evolution towards 6G. One lesson learned from migration to 5G was that we need to limit the number of deployment options. So following this principle of simplification we had in Hexa-X-II, and to be brief, 6G will be standalone from the beginning, and the core network should be an evolution, an enhancement of the 5G core. And for 6G RAN, it will be gradually deployed in coexistence with 5G. We will use multi-rate spectrum sharing implemented in 6G from the beginning to allow dynamic allocation of spectrum resource between 5G and 6G. Then we built this system blueprint, and indeed it is a realization of the 6G platform I introduced in the beginning, providing flexible set of service to application. So at the top of the layer, we've got this application layer that represents the end user or enterprise application. And then we've got this application enablement platform layer that provide exposure of services towards application ecosystem, so they can interact with the underlying network. So it provides some network applications that exploit data from the network. It provides also a simplified or abstracted API from both the network service and the management and orchestration service, so developer can use them without the need to be telco expert. And also, as in 6G, there will be multiple 6G service provider. We have this aggregation producing the ability to compose multiple service from multiple provider. Then if we look at this network function layer, we've got, starting from the RAN, it shows a single RAT architecture with 6G UE that connect via this 6G radio interface towards a core network without any complex inter-RAT multi-connectivity as compared to 5G. And for the core network function, there will be an extension of this 5G core using a 5G core network function and possibly new core network function specific to 6G, and for example, to provide these beyond communication services, like having some function for sensing management function, or functions to provide AI as a service towards developer of applications, so they don't have to manage AI related infrastructure and tool. Then we've got this infrastructure layer, and in this infrastructure layer, the main point is this cloud continuum, where we will have a compute continuum from device to edge and cloud. And then on the right hand side, you've got this pervasive functionality that affect all the layer and as well as the other pervasive functionality. Starting from the bottom, we've got this data in AI framework that integrate respectively DataOps and MLOps. Then we've got this management and orchestration framework that rely on intent-based management approach, multi-platform orchestration, and closed-loop control. And we also have this security and privacy framework that will secure by design the system. So this is a detail about the last iteration of our system blueprint. And then now looking at the bottom-up approach. So here systemization involves that we study some technical components or enabler, and that we assess how they contribute to performance and they impact the sustainability aspect. And the different components that are going to be integrated in the different block of the previous system blueprint, they will come from the enabler developed inside the different work package of Hexa-X-II, but also we have a look at the enabler coming from this other SNS-JU project, so we can check any miss from Hexa-X-II. And so in Hexa-X-II, the SIG-G enabler mainly relate to architecture. We've got several enablers like for data-driven architecture, for network modularization, virtualization, and cloud transformation. Also looking at new access and flexible topology involving, for example, non-terrestrial network integration or and also looking at mechanisms, protocol and function for network beyond communication, for GCAS, and device offloading. And we also have some enabler related to future device and flexible infrastructure. We have a multiple enabler related to the radio at the physical layer, but also looking at enabler for radio protocol involving new some paradigm shift in the design of the protocol stack, or looking at some more evolutionary track like mobility procedure. We've got enabler related to security and privacy and end-to-end resilience, as well as several enablers for smart network management and also intent-based service management automation. So for sake of time, I won't go into detail on all of those enablers. And I just want to give a quick feedback from what we did from the analysis of the enabler of SNS-JU project that we invited for the first workshop. So as already pointed out by Miko, we want to check any undercover or missing enabler in Hexa-X-II, but that are important for the SIG-G platform, and so we want to consider them for this overall system blueprint. And so far we have looked at those different projects, and for example, we have looked at SIG-G NTN, providing a deep look at non-terrestrial network and integration with SIG-G. So it provides much more than what we have currently in Hexa-X-II. We've got also SIG-G Shine, which focus on in-X subnetwork. So both of those projects indeed can refine our own enabler that we call network of network, where we consider network of subnetwork included in then in-X subnetwork, as well as other networks such as NTN. Then we also have enabler coming from deterministic SIG-G and predict SIG-G that relate to this determinism in the network. So for that reason, we added some technical requirement for the SIG-G system. And we also have this enabler for time-sensitive network, as well as also aspect from the predict SIG-G on cross-domain determinisms. And then we've got also FlexScale project, which will provide some enabler related to high-speed and energy-efficient transport network with programmable transceiver. So it will nicely complete what we have in the network function layer of the system blueprint. Then the next project we looked at was rigorous and OAuth, mainly from the security and privacy and resilience aspect, where we thought that this DevSecOps framework from rigorous would be a nice fit for our security, privacy, and resilience controls that we are developing in Hexa-X-II. OAuth provide also enabler related to network digital twin and desire 6G for aspect related to intent-based orchestration and lifecycle management. So based on all this enabler, we have to decide how we select them. So we have built a knowledge graph-based method for that. We apply it mainly towards the enabler from Hexa-X-II because this is where we have the most complete information from those enabler developed internally. So we have mapped all the selected enabler in the 6G system blueprint. And you can see that we've got a lot of enabler on the pervasive functionality and in the network function layer as well. And we also have this system proof of concept where we developed some gradual system POC with gradual addition of capabilities. And we focus on cobot use case for latency sensitive services on a multi-site deployment scenario and looking at aspects related to management and orchestration, taking into account energy and trust aspect, intent translation, and so on. So we also have provided the result of evaluation from the system POC in our latest deliverable that was published in September of this year. So I will stop there. And I want to highlight that we are looking towards this workshop to get more information so we can integrate and analyze some enabler coming from SNS-JU project to complement our enabler and update our final system blueprint. So I will stop there. Thank you. And I think we have maybe I need to check if there is a question in the chat, but
no, Sylvaine, you may go on.
No,
go ahead.
So maybe we can move to the next presentation, and it will be a presentation from Christos for Edward 6G project.